you believe it? China has built a piece of land-black technology that moves faster than most airplanes, reaching an unbelievable speed of nearly 800 kilometers per hour. The moment this technology was revealed, it shocked the entire world. Even the United States, long admired for its cutting-edge innovations, was stunned and quietly envious. Because if this project succeeds, China may become the first nation to truly unlock what many are calling a land takeoff mode. This achievement has raised one big question. What kind of manufacturer managed to create something this advanced? The answer leads us into one of the most fascinating engineering stories of our time. In 2021, China announced a breakthrough that instantly sparked global attention. A new ultra-advanced, fully Chinese-developed project made its debut. A high-temperature superconducting high-speed maglev engineering prototype capable of reaching 800 kilometers per hour. This train is the world's first high-temperature superconducting maglev, more cost-effective than Japan's system, and so innovative that even American researchers couldn't ignore it. To understand how impressive this is, remember that most commercial aircraft in China cruise at around 800 to 900 kilometers per hour. That means this train is approaching airplane-level speed, while staying on the ground. According to official reports, this machine was developed by Southwest Jiaotong University, an institution that has spent decades researching magnetic levitation. The train's body is made entirely from carbon fiber materials, making it both lightweight and incredibly strong. The front of the vehicle uses a cutting-edge aerodynamic design that minimizes air resistance. Under the train sits a superconducting system, while the track below contains permanent magnets. When the system is activated, the train doesn't just rise slightly. It achieves a stable, self-balancing, never-derailing, suspended state. What makes this train truly revolutionary is the cooling method. Japan's maglev trains use liquid helium to bring their superconductors down to extremely low temperatures, around -269 degrees Celsius. China, however, uses liquid nitrogen at -196 degrees Celsius. While both are extremely cold, liquid nitrogen is considered high-temperature superconductivity because it's much warmer than helium. China chose nitrogen for a practical reason. Helium is expensive and globally scarce, while nitrogen is cheap, safe, abundant, and easy to produce. This decision alone allows China to cut its maglev operating costs nearly in half compared to Japan's system. One of the most astonishing features of this high-temperature superconducting maglev is that despite weighing 12.5 tons, it can levitate even while completely still. Because the system generates almost no resistance, the train can be pushed forward with just a light touch, almost like a leaf floating on water. This happens because, when cooled with liquid nitrogen, the superconductor and the magnetic track create a pinning force. This force combines attraction and repulsion, locking the train into a stable position. It's similar to a nail driven deep into wood. It simply won't move out of place. The result is that the train stays suspended in the air at a precise distance, with full stability in every direction. Since the train never touches the track, there is no friction. And without friction, the speed potential becomes extraordinary. Around the world, magnetic levitation systems are usually divided into two types: normal conduction and superconducting. Shanghai's Pudong Maglev, which uses German technology, is a normal conduction high-speed system capable of around 400 kilometers per hour. China's new high-temperature superconducting maglev, however, is something entirely different. It is 100% self-developed, with completely independent intellectual property rights. Naturally, when China revealed this train, some foreign critics immediately claimed the technology must have been stolen. But that accusation quickly fell apart, because the United States does not even have this type of maglev technology. There is nothing to steal. China created something entirely original, something no other country currently possesses. In the global landscape of maglev development, Japan's low-temperature superconductivity, Germany's normal conduction, America's aluminum-based system, and China's existing mid- to low-speed trains, China's new high-temperature superconducting maglev stands in a class of its own. It is the world's first of its kind, marking a technological leap that didn't imitate anyone. The progress reflects China's broader shift from following and learning to leading and innovating. As China's railway system continues to evolve, the country has moved from being a technology importer to becoming a global pace-setter. One of the most exciting features of this new maglev system is that it achieves true unmanned operation, fully controlled by remote computer systems on the ground. Instead of traditional rotary motors, it uses a linear motor, which produces greater power and enables much higher speeds. Southwest Jiaotong University began researching maglev technology back in the 1980s. In 1997, China officially launched its high-temperature superconducting maglev project under the National 863 program. After decades of experimentation and development, the technology finally matured enough to step out of the laboratory and onto test tracks, marking a historic engineering milestone. Maglev trains offer tremendous practical advantages. Since there is no wheel-rail contact, there is no friction, no grinding, and no vibration. The ride is incredibly smooth and stable, even at high speeds. At over 300 kilometers per hour, the noise level is only about 65 decibels, similar to a person speaking loudly. It's quieter than many cars. Energy consumption is also remarkably low. A maglev train uses about half the energy of a car and only 1/4 the energy of an airplane. There are no harmful emissions, maintenance costs remain low, and the system is environmentally friendly. Researchers believe high-temperature superconducting maglev is ideal for high-speed and ultra-high-speed rail systems. Even more exciting, the development team plans to integrate the technology with vacuum tube systems. In theory, a high-temperature superconducting maglev operating inside a low-pressure tube could reach up to 1,500 kilometers per hour, allowing passengers to travel from Beijing to Shanghai in just 1 hour. This would be faster than most commercial flights when you factor in airport delays, security checks, and boarding time. Humanity's pursuit of speed has never stopped. From horses to steam engines, from automobiles to airplanes, every leap forward required decades of trial, error, and innovation. Now, as we search for faster and more efficient transportation, maglev technology is emerging as the next game changer. If these trains reach airplane speeds while offering smoother rides, shorter waiting times, and greater comfort, they could transform daily travel and spark massive economic development. Building and maintaining maglev tracks is cheaper than airports, and the passenger capacity of these trains could far exceed that of planes. Instead of replacing aviation, future ultra-high-speed maglev trains could work alongside it, creating a new world of travel efficiency. China's new high-temperature superconducting maglev marks a major milestone in global transportation technology. It represents not just a leap forward for China, but a powerful symbol of what the future of ground travel could look like. As development continues, China's role in shaping the next era of transportation is becoming increasingly undeniable. The future is moving fast, and China is leading the way. If you enjoyed this story, don't forget to like, comment, and subscribe for more incredible content. See you in the next video.